Thank you very much. I'm Patrick Jones from ICANN's Global Stakeholder Engagement Team. In this session, I'm going to set the stage for the rest of the panelists. I'll be talking about the root server system, the root zone, the operators and the entities that are involved in the root server system, and talk about some of the key actors in this stage of the system. Then there'll be other speakers in the same topic area that'll provide more in-depth discussion from their perspective in the DNS. Get a little bit of a recap that what we're going to talk about is based around Internet Protocol addresses. So these are the numbers in the Internet Corporation for Assigned Names and Numbers part of our world. IP addresses are the fundamental identifier on the Internet. All devices that connect to the Internet rely on an IP address. And it can be in either IP version 4 or IP version 6. We have two examples in the slide if you're not familiar with those. Provide a little bit of a distinction between the root zone itself and the root servers that deliver the root zone, deliver the content of the root zone. The root zone is the starting point. So if you were interested and you wanted to see what is in the root zone, you could go and either download a copy of the file or pull up a copy of the root zone. And you would see that it is the list of top-level domains and all the name servers that are associated with those top-level domains. It is managed by ICANN, and we follow community policy around the distribution of the root zone. The content of the root zone is compiled and distributed by the root zone maintainer, and it is served, the same copy is served by all of the root server operators. The root servers themselves, they respond with the data. The figures on the slide are a little off. If you're interested, you can go to root-servers.org right now, and you could see the total number of instances. As of this morning, it was 929. So the figures in the slides, a little bit off, but these fluctuate over time. Copies of the root servers are added quite often, and so the operators that serve the root zone will add instances or subtract them from time to time. Their role is purely technical. Their job is to serve the root zone, and this is the responsibility of the operators that are doing the service. There are 12 different entities that are involved, and their focus is around a reliable and stable service that is accessible to all Internet users. They focus on technical cooperation, and they're very diverse organizations. They differ. Some are corporations, others may be academic institutions or consortiums, and they're in different, they're distributed around the world. What they are not involved in is in the making of the policy, and they are not involved in changing of the data. They only publish, and they're not the authors and editors of the contents of the root zone. So their responsibility is around careful operation of the service and in suggesting some technical modifications. And their very focus is to make sure that it is delivered in a stable, robust, and reachable manner. So a little bit of more information about the root server system itself. It has grown over time. Between 83 and 86, there were 4 addresses that were serving the root server system. As the needs of the system have grown in response to technical demands, more and more addresses have been added. With the addition of IP version 6 in 2008, the root server operators will have a IPv6 and an IPv4 address pair, And again, as I mentioned earlier, the number of instances, it changes over time. We're now at 929. Numbers are approaching 1,000 worldwide. ICANN operates one of the root servers, and we service through over 100 instances worldwide with our partners. The root server system, all the other operators in the system agree to follow the same principles, that they operate this for the common good of all the internet users. The IANA function is the source of the DNS root data, and they follow the technical standards and expectations that are defined by the Internet Engineering Task Force. If you are interested, there is a long document that's been produced by the Root Server System Advisory Committee. It's called RSAC 23, and this provides all of the detail around the history of the root server system. As I mentioned, you could go to root-servers.org right now, and you could see a visualization around the world of the number of root server instances and where they're located. For ICANN, this would be the root server operated by ICANN is called LRoot, and there are several copies of LRoot that are here in Russia. I believe several located in Moscow. This visualization provides a description of how the root zone is managed. Change requests come from the top-level domain operators into IANA. The request then goes to the root zone maintainer for distribution across all of the root server instances. The oversight for the provisioning side is a new body called the RZERC, and this is the Root Zone Evolution Review Committee. This was one of the entities that was created out of the IANA transition. So it's a new body. The oversight body for the resolution side is the Root Server System Advisory Committee. This is one of the advisory structures. It's part of ICANN. The Root Zone Evolution Review Committee has oversight for proposed architectural changes to the content of the root zone, the systems that are used in executing changes, and the mechanisms for how the root zone is distributed. There are 9 participants from the different advisory committee structures, as well as from our generic name supporting organization, the country code name supporting organization, the engineering task force. ICANN board has representation there, as well as the public technical identifiers and the root zone maintainer. This committee presented at the most recent ICANN meeting in Barcelona, and believe their work is also available on the ICANN website. I'm going to skip the myths and go to a description of the Root Server System Advisory Committee. Now, their role is to advise the ICANN board and ICANN community on matters relating to the operation, the administration, security, and integrity of the Internet's root server system. It's a limited scope, and that is their focus. They produce advice, and in the past 2 years, they've been producing quite a lot of new documents. The root server operators themselves are represented inside this advisory committee, but there's now a growing pool of technical experts that are participating in what's called the RSAC caucus. This shows where the Root Server System Advisory Committee sits within ICANN. There is one advisory member, a liaison on the ICANN board from the Root Server System Advisory Committee. And it is composed of appointed representatives from the root server operators themselves. They have alternates and liaisons. Now, the RSAC caucus is this is a new way for technical experts to participate in the review and in recommendations to the board. It's a number of subject matter experts, and I believe there may be only one from this region that's represented within the caucus, so this is an opportunity if you're interested in the functioning of the root server system. There is a way to express your interest and become part of the RSAC caucus. The RSAC has inward and outward liaisons, so they have liaisons with IANA, they have liaisons with the root zone maintainer, the Internet Architecture Board, and also with other parts of the ICANN structure. For the RSAC caucus, there are, as I've mentioned, 100 technical experts. They, in order to participate, you submit a statement of interest, and then you can participate in the some of the work parties that they have underway. There's a number of opportunities to be involved right now, and if you're interested, you can apply at rsac-membership@icann.org. One of the more recent documents that's been produced by the RSAC is about a proposed governance model for the root server system. This came out in June of this year, and it is currently with the ICANN board, but it is expected that this document will be published for community consultation, and that will be something that we really hope for quite a bit of engagement, particularly from this community. If you are interested in this document, we encourage you to follow this process, and I know you'll be hearing quite a bit from ICANN and our engagement team about the ways to participate and comment in this process. These are the current work parties that are underway. RSAC is looking at the service coverage of the root server system. They're studying modern resolver behavior and packet sizes delivered to the root. There are ways to participate, and we encourage, if this is something that you're interested in, again, reach out and follow this work, and there are ways to become more involved. RSAC as an advisory committee is becoming more and more transparent about the work that it does. They're publishing minutes, they're providing updates at ICANN meetings. There are sessions that you can follow and participate in at either, if you're not at an ICANN meeting, you can follow remotely. There are tutorials and other documents that they're publishing all the time. And so this gives a good explanation of the structures, how they function, and what is happening within this group. For more information about RSAC itself, you can go to the webpage. You can send your general questions to ask-rsac@icann.org, and also you can follow the work of the ICANN caucus on the ICANN website. Now, I think this takes me to the end of this section, of my part of the session. The rest of the speakers in this section will talk about the root server system and how it's evolving and some of the new developments that are coming up. So I can turn it back to you.
Спасибо большое. Есть ли вопросы к Патрику?
Thank you very much. Do you have any questions to Patrick? For Patrick, we will give you a microphone. Please introduce yourself. Sergey, does it make sense to involve non-technical experts? For example, experts in linguistics who know how to understand some things, right? What should they involved in? Well, for example, there are good domain names that counter attacks. Does it make sense to involve non-technical experts to this work? I think this is not a question for Patrick. I will try to answer it instead of him. I think this is more of a domain name marketing issue. There are linguistics experts there, and they have been involved for a while. Now, in terms of the operation of root servers, this is a strictly technical aspect that our expert does not work with. So linguistics part has nothing to do with this. Do you have any other questions about the subject of this presentation? Vasily Dolmatov. So, there is a whole range of long-standing concerns about the distribution of the zone, about the fact that it's all concentrated in one place. There is a number of projects currently that suggest other technologies, EEDNS, and there is a similar one being developed in Russia and in China. So what does RSAC think about this, how to counter them? Are they planning to use those or not? Thank you very much.
Yeah, so I think with the publication of this new mechanism for governance, that model could include some of the discussions of other ways of mechanisms of delivery of the system, and so say wait for the community consultation about the root server evolution process, but this doesn't foreclose any. This is a new model that's being proposed, and there'll be opportunities for the community to weigh in on that process.
Спасибо большое. Я думаю,
Thank you very much. Well, I think we will wait to have more questions. Thank you very much, Patrick. I'm going to ask Olga Makarova from MTS, who will discuss the role of that DNS plays in the operator's work. Thank you very much. Hello. Well, why did we decide to talk about DNS from the point of view of the operator? Well, that's because we are the only organization in Russia that have installed an instance of a DNS root server. So I would like to tell you about our experience. So, well, we're not a registrar, domain name registrar. This is not our area. Why did we need this at all? We were looking at trends, worldwide trends. There is the famous Cisco Systems report saying that mobile use is growing and that content is expanding too. I will go into more details about why it's important later. Video traffic is also growing. Games are also growing. That's so-called heavy traffic. It can all be loaded into CDNs. So smart users, their numbers are growing. It used to be in the 2000s that 120, 150-second loading time, page loading time was normal. However, today an operator believes that 8 to 10 seconds page loading time, that's what's normal. This is for the top 100. This is an interesting slide. When I was looking at it, I was jealous of domain registrars because the number of domains registered is larger by a factor of 4 or 5 than the number of users. This number was lower before. The main site owners are trying to get into CDNs. CDNs are expanding their public DNSs, etc. But why we don't need that yet? So currently, here's what's happening. In the near future, if you look at the top 100 queries from users, you will not find 2 queries that are identical. This means that users are looking at a very large range of different sites. This is looking, even if you discount CDNs and malicious sites, we're talking about 2 billion. So as a rule, network and traffic, so those top 10, they change all the time, right? This is a snapshot from one day. I took it off of Alexa site, but if you look at the site on the next day, this top 10 will change. That's to show that user queries are changing all the time and they're expanding. However, traffic distribution is not evolving. Most traffic are generated from the resources here. I'm talking about Russia, but I believe that the statistics would be more or less, and the distribution would be more or less the same worldwide. So let's say we've got 1,800, right? And then the rest is 2%. Okay, so at some point we knew that at some point we will face the following obstacle, that the client will need to be able to find sites quickly. However, I know that as of today, we were thinking, shall we include DNS in this list? But there are issues everywhere. And the last stretch, there are some the interfaces issues arise with content providers, even at interfaces when ads are loading, because ad aggregators, they place their content depending on their financial considerations and not depending on client needs. Also, there are different approaches, right? For example, you can't improve access to Counter-Strike if one server is in one regional operator and then another server is at a different regional operator, and they don't follow the same logic, right? That happens too. Sometimes a server is installed at a large operator that might want to sell access.
And we have analyzed every possible aspect and to try and see whether we should include the DNS into this long list. In the past few years, we haven't had any problems with DNS systems. Well, by the way, this is the cross-section of our network as of the fall of 2018. Up until the fall of 2018, the CDN could be received within the region, while the traffic went right up to Moscow from the Russian Far East, because the DNS server believed that it was the best way to route the traffic. when we kicked off the project, we have not faced cases like that. This is the first case ever. We will look into it. But actually, we decided that there was nothing that could prevent us from launching an LRoot server instance. And let's see what happens. When we discussed this project, we looked into two options, either have 1 gigabit per second or 10 gigabit per second. We decided to play it safe. Well, and for the instance, the traffic, the data transfer rate was 1 gigabit per second. We decided to go ahead with this option and see what happens, and then, if necessary, we would switch over to 10 gigabits. What just happened?
Это... Вот. Мы сейчас вернемся. Все, я поняла. Это я...
Let me go back to the relevant slide. So when we kicked off the project, we waited for a week, for 2 weeks, and then for a month, and we were extremely upset when we saw 15 megabits in this pushing server. The traffic wouldn't go higher than 15 megabits. An operator has a different mentality. It's difficult to say whether it's a lot or not, but like I said, operators measure traffic in slightly different terms. This is the LRoot instance traffic and traffic from other caching servers that are engaged in pushing real traffic, if you will. 300 to 400 gigabits as compared with 15 gigabits set us extremely upset. We decided to look into this issue in earnest. The button gets stuck all the time. So anyway, we went to the DNS ICANN statistics website to see how many how many queries went to our server. It turned out that it processed about 20 to 2,500 queries per second. And the second thing that we saw is that the LRoot server instance was the second most popular server in Russia in terms of processed queries. Overall, 10,000 queries are processed by LRoot service instances in Russia. Then we we have no idea who the second owner is, by the way. Then we drilled down into the regional breakdown, and we saw that the greatest number of queries processed were LRoot service queries from the Asia-Pacific region. And it set us thinking, because the question was, does it make sense to have the 10 gigabit LRoot instance, because the workload would not be sufficient in either case. We focused on our needs primarily, as I have already mentioned, and 23% of the queries were processed for our needs. 33% of the queries were processed. 33% of the queries came to our instance from abroad, including Asian countries, which is quite weird. it takes a long time to route a query from Hong Kong to Moscow, and Hong Kong was the most popular location, by the way. So, like I said, it takes quite a long time to route the queries from Hong Kong to Moscow, and we decided to identify the root cause for rerouting this traffic to the LRoute server instance. We received the statistics that we required. We were no longer upset about the low amount of traffic. But unfortunately, the iceberg theory came into work, and we only saw the tip of the iceberg, which is 1/8 of the overall problem. These are the outstanding issues that have yet to be settled. These are the questions that we would like to discuss with ICANN. And right now, it's difficult to discuss these questions because we're using one approach as we have no idea whether other operators in other regions follow suit. It would be interesting to do a benchmarking analysis. It would be quite useful to be able to understand what's happening when one of these servers is attacked. Please do not address any questions to me because I have a long list of questions that I'd like to address to ICANN. I'm sorry, but would you please state this question so that translators are able to translate them into English? What's the correlation between the traffic distribution from the LRoute server instance with the regional queries breakdown? I'm interested in the regional breakdown. What I mean is, let me explain the essence of the question because my current interpretation is totally different from the one I had when I wrote them down. So, like I said, our traffic is 15 megabits. We have 2,500 queries, right? And what's our region? It's Eastern Europe, right? If we take another instance which is not operated by a carrier, and if we take a look at the workload of the server, we have to correlate the number of queries and the traffic. I have shown you a number of slides with a regional breakdown. For instance, a server based in Jakarta, does it have the same traffic distribution? We don't need data on specific customers. We do know that there are some things to be considered. Anyway, the next question is, have other carriers in other regions installed LRoute server instances in their regions? We can discuss this issue with those operators who do have LRoute servers instances. We can discuss this issue with ICANN. It's necessary for us to understand whether our instance operates effectively and what is the correlation in general. The third outstanding issue is as follows. If there are 10 gigabit servers, in that case, there should be instances for such servers. If there are, what regions run such instances, 10 gig instances? We have looked into several options of rolling out the LRoute instances. Actually, we did not choose the LRoute server immediately. We tried to compare different instances of different root servers, and we're still unclear whether the LRoute server is the most effective and efficient one, and what criteria should we be guided by when selecting a root server. And the last but not the least bullet on this slide is as follows. When we have to talk to the law enforcement bodies responsible for cyber attacks and so on and so forth, we tell them all the time that the number of identities is higher than 13, and they will be able to cope with the traffic if one of the servers is cyber attacked. I have no idea whether I'm right or wrong, by the way. So we'd like to get specific examples and accurate figures so that we are able to discuss that in earnest. And we are quite open to any discussions. We'll be happy to disclose any piece of data that you might need. And the last part of my presentation, well, I'm not going to even mention the GDPR, which is another buzzword that we're all sick and tired of hearing. But this is the transborder traffic shown in the slide based on the global internet geography. 50% of the traffic, international traffic, goes to Europe. And this is another interesting issue. Does this distribution of the international traffic have any influence on the workload and the distribution of the workload among the root zone servers? That brings me to the end of my presentation. Thank you so much. Are there any questions from the floor to Olga? Well, if you do, if you can take any of the questions listed in the last but one slide, you're more than welcome to do so. Thank you, Olga, and I guess we will be in for a heated debate. Well, actually, we do have a question. Olga, would you please come back to the stage?
John Crane with ICANN. It's not actually a question, it's a comment of please come talk to me so that we can make sure that there's a communication with the people running LRoot inside ICANN, because they have a different view on data than you do. So maybe together we can figure some of these out. And also, I will talk to them, and hopefully you can talk to them too, and we can encourage the idea of actually getting some of the local operators together to share experiences. It's something we've discussed in the past, but we never got around to doing. And I think having those various folks who are doing us and the industry a service by doing this talk to each other might be a good idea. I think we need to share some operational experience. So come talk to me and I'll make sure that the correct introductions are made and we can look at some of this data, because 25,000 queries per second does not sound like a lot, but on an LRoot instance, that's actually quite high. I was surprised by the numbers. There are many that are much smaller than that.
Got it. And that's exactly what I stated in my presentation. We are quite open to any discussions and any form of collaboration. I will leave my contact information with you, and let's work on that. Great. This is great. We have managed to establish some form of dialogue, and collaboration is always welcome. This is the best outcome for any forum. It's quite an interesting view of an operator on the DNS system. How to reduce the response time and how to provide data faster. And it would be quite logical to now give the floor to David Conrad, the CTO from ICANN. I'd like to invite him to the stage. He will brief us on the hyper-local root service. And he will share with us the follow-up ICANN plans in this regard. The floor is all yours.
Thank you very much. I'm David Conrad, ICANN CTO. Next slide, please. Oh, I do that. See if I can figure that out. Oh. There we go. Yeah. Oh, okay. Got it. Thank you very much. Okay, to start off this talk, I'm talking about hyperlocal, which some of you may have heard of. This isn't actually a new concept. It's something that's been around for, I believe, at least 15, maybe 20 years. And it's a way of decentralizing root service. As some of you, most of you perhaps know, root name service is almost identical to name service provided by any other zone. The primary difference is where the name servers for the zone are obtained from. With the root service, it's actually done via priming query. With regular zones, it's obtained via referral responses. And once the cache is primed, the root zone operates just like any other zone. The other differences are the root has as you're aware, a slightly different organizational structure, and the resiliency requirements for the root zone are significantly higher than most zones. But the truth remains that if the root servers are unavailable, the entire DNS namespace will be unreachable, and eventually the DNS will sort of stop working, and as a result, the internet will most of the internet will sort of stop working. One of the main drivers behind the whole hyperlocal concept has been a growing risk that we're seeing within the root server community and the internet network operations communities at large. You know, historically and currently, the root server system as it currently operates has worked essentially flawlessly. There have been a few incidents in the very distant past where there were some problems with some root name servers back when there were like 3 or 4 root name servers. There have been attacks, but none of those attacks actually resulted in any noticeable degradation of service to end users. It was noticed in monitoring systems, but not by end users themselves. But the problem is that the attack capacity is growing quite rapidly. And that means that there is a risk that the root service itself could fall as a result of a sustained denial of service attack. This leaves us with sort of 3 options to mitigate this problem. One is to try to limit or reduce the attack capacity. Another would be to expand root server capacity. And then the last, which I'll be talking about in some detail, is decentralizing root name service. So talking about the first, the limiting or reducing attack traffic, this really is sort of the ideal solution because if you can actually reduce the attack traffic, then you can survive on the existing capacity. The problem is that there are a whole bunch of attacks and vectors of those attacks. Reflection attacks, amplification attacks, volumetric attacks, which combine both of those, the reflection and amplification. And these are driven by compromised hosts, botnets, all sorts of different malware. Part of the problem is, as we have become increasingly painfully aware, S in IoT stands for security. That is, there is very little security in most IoT devices. They're easily compromised and turned into small attack vectors, but you combine enough of them and you actually have a pretty impressive attack vector, as folks like Dyn and others noticed. And also, we still haven't figured out how to do source address validation very well. The best common practice 38, BCP 38, has been out now for 15 years, I believe, and we still don't have sufficient penetration of that standard to protect us from attacks with spoofed IP addresses. So looking at expanding root server capacity, as Patrick has mentioned, we have 13 server addresses, actually 26, 13 IPv4 and 13 IPv6, run by 12 operators that map into somewhere around 1,000 servers, depending on what statistic you use. It's either 929 or 1,035. And resolvers actually choose the root server instance based on the quickest round trip time to the resolvers. Some resolvers actually do a random selection, but sort of the more advanced resolvers all try to do sort of banding to figure out what the fastest root server response is and then sort of home in on that one. This works in almost all cases. It's actually pretty effective. Since there's so many servers, if one server is taken out, if one of the root servers is taken out, there are 12 others that can respond to queries. And by and large, this has actually worked pretty effectively. There haven't been any significant attacks on the root servers in years. That first graph on the right there is of an attack in 2007. One specific root server, that was actually the L root statistics for the L root server, and it showed that it was pretty negatively impacted, but the other root servers were able to take up the slack that L wasn't able to cover. The graph below is from 2015, and it shows a good number of the root servers. 4 of them were actually taken off the air for a period of time, but there were still others that were able to cover the query load. Unfortunately, it doesn't mean that an attack won't happen in the future. And the reality is that the cost of mounting a DDoS attack is actually going down very, very rapidly. But the ability to ramp up capacity still is, how much money do you want to throw at adding bandwidth or deploying more instances? Unlike pretty much any other zone, there is no single administrator for the root service itself. There are 12 independent organizations. There aren't any service level agreements among those organizations, and there's no sort of service-wide funding model. Some of this is going to be discussed with regards to the RSAC 3738 governance model that Patrick had mentioned earlier. And it will allow for greater accountability across the root server operators to ensure that they're able to or encouraged to upgrade appropriately. And it may provide a path for a funding model that will allow for those upgrades to occur. But ultimately, a lot of folks, particularly in the technical community, believe that we're sort of in a unsustainable path. The exponential increase in capacity of attack is something that we will not be able to throw enough money at over time. So looking at a different approach, there are a large number of resolvers out there, and resolver operators sort of are in the business to ensure that they have a stable name service. Within their networks, they mitigate the denial of service attacks within their infrastructure and or fund increases as necessary for their customers. In 2015, there was an RFC, RFC 7706, that was published by the IETF that described a set of techniques that some resolver operators had adopted to provide better service for some value of the variable better for root queries. Some of the attributes of the RFC 7706 approaches were it provided faster responses for NX domains, reduced latency for queries in general, improved privacy since it would keep queries local instead of having them go across the world to wherever the root server instances were. Right now, the IETF is revising RFC 7706. It's being updated to include the lessons that have been learned over the past few years. And the new approach, the revised approach, we'll call hyperlocal to make a distinction between that approach and the 7706 approach. And I'll try again. There we go. So hyperlocal is actually a set of techniques that resolver operators can use to mirror the entire root zone and use it locally. Basically, it means that the resolver respond authoritatively to queries for the root, but only for the folks who can access that particular resolver. Mirroring the root zone means that the root namespace is available, is potentially available from any resolver. So that decentralizes the access to the root namespace to millions of servers. As a result, any attacks against the root name servers themselves would go unnoticed by the folks who are behind these hyperlocal resolvers. For security, the hyperlocal resolvers would need to implement DNSSEC validation. It would mean that the resolver operators wouldn't be able to modify the root zone without being detected, resulting in essentially a denial of service for anyone using that, which would undoubtedly result in people complaining to the resolver operator that they made a mistake somehow. How do we actually do something like this? Well, right now, the root zone availability is sort of limited to a small number of clients, the existing root server operators and the 1,000 machines that are currently implementing the root itself. Hyperlocal supporting zone availability service would need to be expanded to handle hundreds of thousands to millions of clients. Right now, I believe estimates are showing about 50,000 resolvers consistently query the root, but the total number of resolvers, if you look at all of the open resolvers out there on the internet, is upwards in the millions. If each one of those was to mirror the root zone, that would mean they'd need to do a zone transfer of the root zone or gain it some other way. ICANN right now is actually investigating a service for providing the root zone to hyperlocal resolvers. This is different than actually providing root service itself because it's actually providing the entire root zone. We don't have to care so much about the timing characteristics. Querying the root servers themselves, you need responses in the sub-millisecond. Pulling down the root zone in order to serve it locally, that's configured on the zone timers. So it can be on the order of 12 hours or so per day, twice per day is what the current root zone is distributed at. Resolver operators opting into the service could choose among hundreds of locations that could use either DNS transport with zone transfer, or we've been experimenting with using HTTPS, which would allow for the root zone to be distributed out on content delivery networks the way any large content is distributed these days. Remember that the root zone is relatively small. I think now it's about 5 megabytes. Since it includes all the DNSSEC information. That's still a relatively small amount of data that could easily be replicated. One thing to point out is that we don't need to do this. That is, ICANN does not need to provide this service. We're looking to do it to actually make it a little better for the community. But the existing server, there are ways of getting the root zone now. Right now, 6 of the root server operators actually distribute the root zone. One of those, ICANN, we actually have set up dedicated servers for zone transfer at those domains right there. The root zone itself is published on ftp.internet.net and http.internet.net, one of the remainders of the earlier days of the internet. And some other folks are looking at implementing provisioning systems that will provide things like the DNS notify messages. So anytime the zone gets updated, a notify message is sent out that allows people to have a trigger for pulling down the zone instead of polling for a new zone. That's actually being done at ISI, and it's in beta test right now.
Ну что, как обеспечить здесь отказоустойчивость? Значит, гиперлокальный подход, он должен быть как минимум таким, настолько же отказоустойчивым, каким является текущая SEO-система, иначе вообще нет смысла действовать. Значит, если гиперлокальный сервис отказывает, нужно иметь некоторую резервную схему. И именно это и будет включено в
And there are a number of different approaches that people are considering, but it's probably worth remembering that this is distributing out the zone to the resolver operators. If the hyperlocal service fails, then you're going to have a lot of unhappy customers of that resolver operator. They'll undoubtedly call up the ISP or other organizations that's providing that service, complain, and it'll undoubtedly be fixed relatively quickly. What is ICANN doing along these lines? We have provided small amount of capital to some of the usual suspects in the development of name server software to help implement the hyperlocal concepts within their resolvers. The results have been a variety of software with the different approaches to implement hyperlocal. All of them seem to be working effectively with similar effectiveness. There are a bunch of different ways to actually solve this particular problem. When and if we actually deliver the provisioning service, we'll assume that the software vendors will update to reflect the new distribution system. If necessary, ICANN will provide funding to help that as well. Finally, the question is this really needed? Is hyperlocal something that we need to do in order to protect the root of the DNS? Maybe not, but it really sort of suck if we were to find out about it because the root went down. Choosing hyperlocal over the existing root service is up to the resolver operator. It's something that's entirely opt-in. It's not something that would be forced in a top-down fashion. People would only deploy it if they thought it was in their best interests. Hyperlocal will be of most value to the resolvers with the most continuous connections to the internet. The situations in which we have packet loss or very high latencies are areas in which having a hyperlocal service would actually make the most sense. If the root server does come under attack, hyperlocal will actually help resolvers respond to queries for root service and thereby keep the DNS operational for the internet as a whole. And with that, I'd be happy to answer any questions anyone might have.
Есть ли вопросы?
Any questions? Right. Yes, I see a question. Please introduce yourself. Alexei, MTS. If you may, is there a trend towards growth of attacks, and is there correlation?
Slide, if you can pull that, that's I think slide 3. That shows the growth of the attacks over since March up until March 2018. So we are seeing an increased growth capacity. Unfortunately, it actually looks almost exponential in nature. Oh, I have to do that myself, don't I? There we go. So the last attack in March of 2018 was about 1.7 terabits per second. It's sort of hard to build an infrastructure that's capable of handling 1.7 terabits per second, focused on a specific set of servers. That's one of the trends that particularly ICANN's board sort of got nervous about and started asking my team, the Office of the CTO, to look into ways of mitigating that particular risk. I believe Gartner is estimating that peak denial of service capacity is probably going to be in the tens of terabits over the next couple of years. So that's one of the reasons that we're looking at doing this sort of approach of decentralizing now, because we don't unfortunately see much of a chance that the capacity, the attack capacity, is going to be going down over time with the proliferation of Internet of Things and other helpful devices.
Есть ли еще вопросы? Хорошо. Тогда
Any more questions? Okay, good. Thank you very much, David Conrad. I would like to ask the last presenter in this section, Pavel Kramtsov from MSKIX. He will talk about the evolution of the DNS system. Pavel, you have the floor. All right, if I may see the presentation, please. I'm not going to tell you anything new. If I say what I'm going to say, but I will kind of just order what's being said today. So there's a lot of talk of privacy and DNS over TLS, DNS over HTTPS that are currently being discussed. David Conrad was just talking about hyperlocal root servers. But really, here's what's important here. In the end, speaking of DNS and namespace, really we are mixing two very important IANA functions. Those are creating domain namespace. There was a question about linguistics experts. Really, we're talking here about the tree for domain namespace. And then the second one is the resolution or reflection of that tree of the domain namespace into IP addresses, right? So the query and the response that we get, it depends on where you went and what you downloaded from there. If you look at the history of the DNS, DNS is really an application, actually. It's not a transport, it's not a network. It's just an application that that converts some mnemonic devices into addresses. Right? We could have developed some other application that would do the same thing. So when we repeat the mantra, one world, one internet, one namespace, we are not going any further than that. Is there just one resolution, or is there an option for converting namespace into address space, right? So this ICANN's mission that has to do with ensuring that internet needs to be unified for every user, and that every user has to see the same thing. Really, if you look at the current internet, is this something still there, that's still there or not? Something is wrong with these slides. It has a life of its own, this pointer. Anyway, like Jeff Houston from AppNIC says, here is the classic recursion key setup in the DNS system. So you've got root servers where everything originates from, right? Then we've got servers that support top-level domains. Then we've got servers that support the lower level domains and other domains. And then you've got the green dot in the middle, that is the resolver. And that's what we ask to find an IP address based on a name. So far, all of the presentations were focused on the top left boat-looking thing. That's because where the recursive search starts from. And so what we say that what if that boat becomes inaccessible, things will go haywire and things will stop resolving. That's not exactly true, because this resolver, the green one, it's also a caching resolver. And so if everything had been working up to then, it will have remembered things. And so for some time, matching the TTL field, that resolver will keep system functional. Now, moving on to DDoS attacks. DDoS infrastructure attacks on the DNS system that David Conrad was talking about. I'm not talking about 1.7 terabyte attacks, that's the latest thing, but the attacks that had been occurring earlier, those raised the issue of the accessibility of those servers. The resolution was to introduce Anycast. We created this setup. We've already seen it, the core root servers and the mirrors all over the world. Resolvers query them differently because every resolver has its own algorithms for interacting with servers. So for bind, for example, they have their own. You look at Windows resolver, it does random selection of servers. So anyway, there are various options here. So for example, you've got a 1.7 attack, 1.7 terabyte attack, and then you've got the Anycast system that kind of folds as dominoes would, right? And then the whole system is inaccessible. You've got the hyperloop that we'll get to it. But in that case, you've got hyperlocal that resolve this. And then we've got David Kaminsky, who says, this is all great, but who said that you will get the queries that you're expecting to get? Right? It's not a given that it's the server that you've queried that's responding to you. Okay, we've got DNSSEC then. DNSSEC is something that ensures that we get a query from the server we need to get a query from. However, in this case, it's not the querying all of these queries, but you've got the chain of trust. And this is also, of course, tied to the DNS KSK key rollover. So where do you install that KSK? On the resolver. Who does the DNSSEC verification? It's the resolver, right? And so the role of the resolver in this whole thing, it expands because it not only serves the final end user, but it also verifies the responses from authoritative servers and verifies whether or not they are actually authoritative. Moving on. Now we've got hyperlocal service, right? In this case, in addition to the validating resolver, it also gets the root. right? You could, in theory, get any TLT zone. You could get any zone of the next level, etc. And also, this is nothing new. Resolver has prefetching enabled, and so, for example, when it starts collecting information from the most popular resources, and IP addresses are reflected there without any queries from end users. It just queries and it expands its cache and doesn't even go anywhere aside from its own cache. Obviously, there is the TTL for all of these records. But here's what we need to remember. For example, if I own and I have a root zone and KSK, what prevents me? That's a question. What prevents me from creating my own validation? Really, in the grand scheme of things, nothing. So the end user, the one that doesn't do validation and that's being served by a resolver, the user won't notice anything in that case. That's just an aside here. So now, let's say, we've got the provider's resolver, replace it with like a goodwill corporation, right? If we believe what Jeff Houston says, there is no reason not to believe him. Then for the European Union, for example, we can say that 86% of their users, they use public DNS resolvers, Google's. And what's interesting here is that they don't even know this, most of them, because that's a decision made by their ISP. They're not the ones that are so smart that they had changed DHCP parameters. It's just their ISP provider that gave them their four eights, and they just use that setup. Okay, moving on. So let's say we've introduced DNS over DNS and HTTPS. What does this mean? We go to Google, look at all the porn we're watching. Everyone knows it because nothing is hidden or so. Let's hide that information from the public and let's start only using protected protocols. So this means TCP. There is no spoofing then. You move directly to the resolver then. And here's what's interesting. Since validation and everything else happens on the resolver, it means that the DNS system potentially is useful for the goodwill corporation, but for the end user, it's really unnecessary in this case because we've got cookies in HTTPS, we've got certificates, we've got lots of other things, and really Chrome, for example, it knows itself where to go and what to query. So let's look at Google's ecosystem, for example, right? GCPS, for example. The gist of it is that we trust some other third party. For Google, that's not the case. They have their kind of accepted and by the public and by Canadian authorities some certificates, and that's the certificates that is used to go to Google Resolver. It's cached by every operator, and that's how their clients work. So you've got your own certification center, your own browser, your own search engine, you've got your own email client. What else do you really need? What else does a regular end user need, really? So Here on this table, it's from APNIC. You see here where we've got DNSSEC and how public DNS resolvers are being used. It's the same questions that I raised at the very beginning. I mean, really, is there anything other than trust in these goodwill corporations that are dictating the development of standards these days? Like, how do we know that they are showing us what we want to see? That's the question, really. Obviously, if you sponsor software development and have a DNS validation go down to end user level, that's not something that exists yet. End user uses a resolver. Some other alternative approach to letting end users have access. That's something to think about. But there is a trend that's going in this direction, and that's a little scary. So that is all I wanted to say. Thank you very much. Thank you very much. This was very interesting. Was logically followed what we had been saying earlier. I am seeing hands up. Good. Yuri Kargopolov, Pasha, the good will corporation. Can we start with this very tool? Yeah, of course. You just install Chrome, and this Goodwill Corporation, it resides right there. You can even install Yandex browser there. No, that's not what I meant. Here's what I meant. What if we download a DNS cache here? And what if we start Goodwill Corporation from that? You understand what you mean? Okay, yes. I mean, the light resolvers, there is already software in place. There are many developers. You can install it on your own computer, and you've got your own resolver right there. Then if you load KSK into your own resolver, the correct KSK, right, then you can, of course, validate anything you want. Answer. What if you don't say if? What then? You can't operate then. You've got to manage everything yourself. This is your own personal responsibility, or like what hygiene, you have to use soap when you wash your hands, like things like this. Any more questions? Yes, please. Just one response. So when I hang out with operators, right? I see that everything is bad. All of the operators, mainly European ones, they all say that you've got to do something with Google. You have to not let it in. Then I go to a DNS forum. I hear that all of the operators have given 86% of all resolutions to Google to Google. I don't understand. Answer. Well, I go to Switzerland, connect to Wi-Fi at any hotel. You move DNS from UDP to TCP, and you see different resolvers. Answer. Well, Wi-Fi's at a hotel, that's not operators, right? I know what German operators and monopolists, I know how they view Google. Wi-Fi is at a hotel. That's what Google was doing. But Wi-Fi at a hotel, that's not just any user. Then you should say 86% of users at hotels. Pavel Kramtsov, I was presenting Jeff Houston's research results on the APNIC sites, and you can read the description of their methods there. Olga, yeah, of course. Maybe I will definitely look there, and maybe some operators conferences maybe they are presenting the wrong answers. Cool. Please use a microphone when you ask questions. Is the situation worse or better in China? Answer. Well, it depends on your point of view. My point of view is, well, I use in China all of the services that I always use, that I am used to using. So, all right. Well, I think that any technical experts, they will know what to do. Well, if you go to China and you know what's going on there, you won't have any access issues, right? Just like Mr. Kurkabolov asked, can I install anything on my computer? Yeah, you can install whatever you want, and then things work. Thank you very much. Any more questions for Pavel or for any of the other presenters? Maybe you've got new questions for other presenters in light of what you just heard. Fine. This is the end of this segment of the forum. We have now lunch scheduled back here at 2:30. Thank you.